that works. So, yep, I'm Jarek Śmietanka. You can find me easily on LinkedIn. So the main guest of today's presentation is cognitive load, particularly the cognitive load in software development. So at some point, I realized that some parts of code and projects that I'm maintaining requiring much more effort for me to start with, to make changes, and I started digging. And this presentation is actually the result of me digging into this topic. So there will be some theory. Don't be afraid. There will be the absolute minimum of theory, but you have to stick with me for a few minutes to grasp what I'm trying to explain to you. There will be like very basics, but quite important ones. Then we will go through lots of use cases, examples. So there will be some Python code, nothing really special, but you will see some Python. There will be conclusions part, and obviously some time for questions and discussions. So I will take all the questions in the at the end of the presentation. So, like, we don't have to wait a little bit longer. Theory. So what is a cognitive load? Cognitive load is actually how much you have to think in order to complete a task as a developer. So generally any task, but today we're gonna be focusing on cognitive load in software development. So, so that's why the developer is mentioned in the definition. In terms of types that you can encounter, mostly you will find two types, the first two types, while looking for the cognitive load subject. But there is a third one, and actually the third one causes majority of discussions and questions regarding this topic. So you're gonna disagree with some examples that I'm going to show because of this third one. So one after another. Intrinsic type of cognitive load. It's the load that you cannot escape from. It's so much tied to the task at hand that it's constant part of your job. For example, if you are, let's say, doing some task regarding taxation, you have to understand what tax is, what are the rates, what terms this domain is using. So you cannot escape from this part, and we won't be focusing on that one that much. There is extraneous type, and the majority of the fun comes in here because we can do something about it. That's the environment we are operating in. So the language, the structure of the project, how the task is actually written, how much do we understand from this topic, how hard is to start working with this particular part of code where we are going to change something or fix something. And the third one, germane, is related how much effort we need to put in order to translate or convert some new knowledge into long-term memory. So generally, in terms of cognitive load, there is like certain number, which is four tokens of information. You can find it that the number is between 3 and 5. So, and one of the documents particularly says 4. So what is a token? It's kind of a information that you hold in your short-term memory, while, for example, reading code base, reading the task at hand, or reading the Jira ticket or whatever you have to start working with. And you may ask, what happens if we reach this limit? So like, It's not like with memory management that the system operational system comes in and says, it's nothing personal. And no, it's not that way, but the difficulty and the effort we have to put in completing the tasks once we exceeding this number of tokens, it grows rapidly, and it is becoming even more easier for us to get disrupted. So that's why we should put attention to how much information is required while working with given task. So that's also reason why we should split tasks into smaller ones, because it's easier for us to store them in our short-term memory. Yep, that's enough theory, as I promised. So there will be lots of examples and cases. Yep. The first one, it's complex conditionals. Each condition that you see at the top, or comparison, or operation, and even negation, it consumes tokens. But our brain likes to give some aliases or names to some concepts. And once we name some concept, and we know it's named well, it costs us only single token. So that's why if we name the conditions which we're above with something that is valid, is allowed, is secure, and then only we mark this code block that, okay, as long as those three conditions are met, we're going further. So that's one thing we can think of regarding the cognitive load. The less operations we have in conditional blocks, it's easier for us to understand why we got into this branch of code. We can go even further with this idea. Our brain likes to get rid of something from the working memory. So if we decide that as long as we ensure that there is no point in further processing of some codes, and we follow the procedure of returning early, so if something is not valid, then we interrupt. Our brain likes to focus on a happy path. So whenever we do some stuff, we're sure that, okay, all the preconditions we already met and we don't have to care about it. If we are in this place, then we should be here. Like there is like no condition we have to think of further. Yep, inheritance, SQL alchemy, like very standard user class, but it's consisted of so many mixins inheriting from so many classes that, okay, let's imagine that you are a developer that is supposed to add something to it, or answer the question whether the user is rejected to perform such an operation. You have to dig through each and every mixin or class in order to find out what are actually the fields for this class. If there is like some override methods happening in between. And you're happy at some point, okay, I understood all these mixins and all this stuff, and suddenly there is like admin user at some point that overrides all the knowledge you already acquired, and you have to even add even more layers on top of your understanding in order to find the answer whether, for example, whether the user is rejected to perform such an operation, or maybe something is within the impersonate user. What we can do about it? Some parts of this class could be translated from inheritance to composition. So that's generally, in terms of cognitive load, the composition is preferable to work so on the other hand is on another side is the inheritance. So it's easier for us to have all this all the fields written down within a class instead of jumping from file to file. Each jump that we have to perform, open another tab, it's like another token of information that we have to maintain in our working memory, short-term memory, in order to complete the task and understand what is going on. So in terms of cognitive load, the rule of thumb is to prefer composition over inheritance. Too many methods, classes, modules, and even services. So that's something that applies to, like, I have seen it more in Java than in Python, actually, but it happens everywhere. So if there are like multiple interfaces, multiple like proxy modules that are not adding much of a value, but they only proxying some access rights, for example, all of this contributes to the total load that we have to make in order to finish some task or understand something. So generally I have seen two definitions. One which is deep module that have very simple limited interface, but really complex functionality. Good example of such a module is Unix code that is responsible for interacting with files. They have literally like 5 or 6 methods, and whole world manages to open files and work with files with 6 methods only. So that's something, and the implementation is huge underneath, but it works everywhere. So that's kind of an example we could have. The same thing I found that applies to microservices that we're kind of popular. They still are. I'm working with some of them, but actually I came to a name at some point while reading that there is a term called macro services. So it's like some part of functionality is actually enclosed in a single service that is like not aligned with definition of a microservice. It could be split even more, but they grown to be microservices, and this is kind of a good way of putting modules between and boundaries between the functionalities. I have feeling that I left some information right here, but maybe I will recall it later on. With each and every Python release, we are excited to see that there are some new features coming in, like Walrus operator, like switch statement, typing as well. So there is like plenty of new shiny things that whenever we are able to change the Python version, we thrilled to, okay, we're gonna use it. But hold your horses. It may fire back on you at some point, because you may put some effort, and this is actually a good way to explain this third type of cognitive load, which is a German type. Because probably majority of you have already made an effort of understanding what the Walrus operator is. And the first paragraph, those two and 3 lines, are pretty much in terms of cognitive load identical to you. I haven't. For me, this first line still consumes 2 tokens, while it's only 1 token for you. So imagine that you are a junior developer that is only discovering Python Arcana, and you have used all these shiny things in the code that this poor little junior developer is going to read and work with. Yep. So we have been living without this operator for quite some time, and probably we still can. But yep, that's how it is. Anonymous functions, really the same concept goes here. Our brain has to come up with some name for this lambda function, because like we are not good at remembering such an expression. Our brain gonna come up with some name for it, which is costly, but that's how it works. What we can do, we can name things properly. Once someone who reads the code agrees with our interpretation that this is actually a good name for this method, like is user a good user, then once someone reaches that line of code, it costs only one extra token to understand what this line actually does, instead of like remembering concept of user being expired, user having some unpaid invoices, and so on and so on. That's how we can tackle the cognitive load. For example, naming things properly, what they actually doing. Yep, probably lots of you, me myself, been studying or at the university or some boot camp, and been taught that you should avoid repeating the very same lines of code over and over again, because like it's bad practice and you're gonna be, I don't know, sentenced to death. I don't know. But in terms of cognitive load, it might not be always the best solution or best approach. Sometimes we gonna extract the common parts into some module, helper, things like that. Too early, for example. The code is still in progress, and we see that there are two concepts that are quite similar, and that's 12 lines of code, I'm gonna make them common and have a helper function. I don't have a good name for it, but I will do it anyway, so I will call it process. And some poor developer later on gonna be thinking, what the hell this process does? Yeah, that's my art, let's say. That's my job of changing this picture. So forgive me my skills, but I was trying to do my best. What else? Avoiding the repetition by all means also might lead to introducing dependencies over some libraries that, like, it might be the only dependency to this library that you have. But you recall that, okay, there was like some method that does filtering, for example, which I could write in a single line of Python with list comprehension, for example. But yeah, I'm gonna use this function from the library I have seen, and that way I saved literally no lines of code, and I introduced a dependency that someone will have to maintain at some point later on. So it's not only thinking about short term, but also long term. That we might start thinking that it might not be the best idea to introduce dependency if we can write it by our own or copy some small method that does the job. Fun fact regarding the list comprehension. So for Python developers, it's like supernatural to use dict comprehension, list comprehension, but I have been talking to JavaScript developer who transforms into Python developer, and he said that it's not that natural. So even small things and quite natural things that are like second skin to us might be a challenge for someone who comes from a different background. Yep, that's my favorite part, because that's actually the point that I'm focusing quite a lot while performing code review. While I'm trying to understand what someone has written, I pointing out things that are not named properly, so I have to think more in order to understand the code, because someone just left a placeholder name somewhere, and I have to think harder in order to find out what the code actually does. So that's my most favorite part, but we are close to an end. Yeah, so someone might, it does, oh yeah, it works. Someone might ask a question, what the process is. Almost every method processes something. What data is, no idea. You might think that, okay, there is some item and there is maybe incrementation. Maybe, maybe not. Maybe it's initialized network connection and we're gonna have like list of network connections as a result. We don't know because there is like no typing at all. Like there is plenty of things we can think about it. Even if it's incrementation, it's whether the question is whether this is pre-incrementation or post-incrementation. We're gonna have list of previous values or new values in this list. So yep, there's plenty of questions, so little answers. Yep, all the abbreviations. If the domain accepts the abbreviation, probably you're gonna end up with the abbreviation in your code, because like that's how you speak about the subject. But imagine that there is someone joining your team and they have to like add extra effort to learn all these abbreviations in order to understand the code. The code is for developers, not for computers. Computers, they don't care about the names, people do. So that's something we should start thinking as well, that there will be someone else reading the code, definitely, and it won't be us, or us in the future, so probably that the possibility that you don't longer recall what the code does is quite high. Yep, so single letters or anything like this, so there is like S probably stands for some, maybe. I and Q stand for item and quantity, because like it's based on the code, but who can tell me what for P stands? Maybe price, who knows, we have to check. So that's like another load, we have to jump into this property, do some like investigation, what this P actually is. Maybe it's not price at all, maybe it's something else. Yeah, that one, I have probably done it myself as well. So there was like, I was working on some script, and I've been thinking that, okay, I'm gonna have list of files at some point, but I ended up with having a single file, but this assignment was left in the code alone and still stays somewhere there. And someone else comes to this line of code and wonders, is this really a user data in this file, or it's really a list of files, but it's overridden somewhere else? So all this stuff contributes to the total load that developer has to take while doing job, or us at some point maybe. Yeah, so that's actually from our code base. Probably it returns string, but always? Maybe not. What this maybe returns to the UID, to the whole operation, or to something else. Maybe there is some condition hidden. Yeah, so as long as it would have like proper name, there is a high chance that we would assume that it's true and move along. But if it's not, then we have to dig deeper. Yeah, you can go also wrong with naming things the other way around. It's like opposition to the process. It's way too much information. Maybe you, based on the arguments list, probably there is like no need to add form submission because like the argument probably says this. So you can go also too far with too elaborative names. So yeah, be mindful about this. So in Java, I have seen like names even longer. And once you think that you already accomplished understanding the name, that then comes a builder as well, as a class that constructs the class that you already understood. Different names for the very same concept. Also translation between concepts is costly one, like between languages. This might have been because of some historical reasons. I have it in my code as well, because like some object used to be called differently, but there was no time in order to rewrite the whole code base in order to accommodate the new naming convention. But yeah, even while talking about some assignment, we have to like, okay, it's channel. So in documentation, it's email, account, or something like this. So like there is like extra layer of translation between you and product owner, for example. Because like cognitive load, it's not only about the code base. It's also about the tickets you read and write. If the product owner, for example, is wanna be author of novels, and they write very long descriptive names that have very little actual information needed for you to accomplish the task, it's also extra load that you have to mindfully ignore some parts of information. That's also part of the cognitive load that contributes to how much time actually we spend on completing a task. That's like quite common one, that things are not actually named the way what they do. I don't know why, but I have seen it quite a lot. The last one is, in terms of reading, it's not that hard. It's a mixture of naming conventions, but it's quite obvious what it is. But imagine that you have to add third property to this code. It's a choice you have to make, and also choices are part of a cognitive load. If there would be a consistent naming convention within the code, there would be no doubt that user permission should be lowercase or camel case. But in this case right here, we don't know. We have to like ask around, find some documentation. I don't know. Yep. We reached the end of examples and cases. I will leave you with some conclusion and grab something to drink. Yeah, read it. Yeah, it's tough. It is. Like, it's a very example of how not to write things better. The blue part is the intrinsic type of cognitive load assigned to a task. So in terms of absolute values, those two green parts are equal. But the bad approach is whenever all the extras I've been talking about, and I will share some of the sources I had, so they have even more examples of like extraneous type of cognitive load that is adding up. So all these smart solutions, new fancy shiny things, all goes to this extras part. Yep. So to some conclusions, what we can do about it and what we should understand about it. We should think about cognitive load while working. So even as manager or someone who writes tasks, someone who completes them, maybe you see in code review that it's something it's not obvious and it might be simplified or renamed at least. So there is like plenty of practice exercises you can do. Yeah, adding some comments, simplifying code base, refactoring. I know it's hard to find time and allocate resources, but it will pay off at some point. Yeah, we have to hide our pride and like being super extra smart developer that knows all the arcanas of Python, and I gonna use all the fancy structures from language while doing the task, and someone else gonna feel the pain that they have to like understand all these tricky lines of code that I have written. So in terms of cognitive load, we should avoid it. We should hide our pride. LLMs, I use them. They are quite good at explaining things or naming things better or suggesting some kind of a structure change. So especially once they have an access to the whole code base, they can jump over and build concepts that are quite tricky to follow. Yeah, and educate others. So like I'm here, you can spread the news, ask me to some other conferences or meetups. I'm happy to be there. There is like plenty of sources on the internet. The first one is actually the main inspiration. It says exclusively about the cognitive load in software development. There is like even more examples right there in comparison to what you have seen today. And some information regarding the theory of cognitive load. So it's not only, obviously it's not only within the software development. Like the choices you have to make while starting the day. You open the wardrobe and you have to think, oh my God, I'm gonna take this t-shirt or not that one, or that one does not fit. That's also kind of a cognitive load that we are dealing daily. Yep. Time for questions. Thank you very much for your attention. Hope you enjoyed, and I'm leaving you with some quotes that I encountered while preparing this presentation and waiting for questions. Thank you very much.